Okay, everyone, we are almost done with our fractions unit. This is the last lesson in our fraction unit. And you have learned about the whole being a circle, a number line from 0 to 1. You have learned about the whole could be a fraction strip. But today we're going to switch it a little bit, and I think you can get it if you just open your mind a little bit. This is lesson 7.12, fractions of a collection. Now, a collection means a bunch of different objects put together. And I have a collection here to show you. I have a collection of Lego figurines to show you. I've got a Harry Potter, a Ron, a Hermione. See if I can hold all these. Another Hermione, and another Harry. Okay, so this is what you call a collection. This is going to be a collection of 5, and the collection is the whole. The collection is the whole. Got me so far? The collection is the whole. All right, now we're going to talk a little bit about the parts of my whole. I have 5 figurines here, so I'm going to say this is 5 parts, 5 equal parts. I have a Harry part, a Hermione part, another Hermione part, a Ron part, and another Harry part. So, 5. It's going to be in fifths. Fifths. My denominator is going to be 5. So what I can say about this collection, if I'm going to use fractions with it, I can say that 1/5 of my Lego figurines are Rons. 1/5. And the reason I can say that is only 1 out of my 5 figures is Ron. So 1/5 of my collection is Ron. 2/5, if I do Hermione, I have 2 Hermiones. So 2/5 of my figurine collection are Hermiones. 2/5 are Hermiones. And Harry at the beginning and at the end, 2 of them are Harry, so 2/5 are Harrys. So if I take 1/5 Ron, 2/5 Hermione's, and 2/5 Harry, I get 5/5 altogether, and that's one whole collection. So keep that in mind. Collection is a number of objects, and this time my whole had 5 objects in it. So my denominator was 5/5. All right, so hopefully that helps you a little bit. Okay, I'm going to start out just demonstrating for you the way this works with collections, because I think that's the best way to show you. So the first problem that I have is with a girl that has stamps, and her name is Jules. Okay, Jules has stamps, and she's going to put them in a book. So to show you, I'm going to pretend that this is my book. And Jules has 12 stamps altogether. Okay? And my problem says she puts half of her stamps on one page and half on the other. Now, how do I figure out how much 1/2 is? Now, I can tell you right now, there's a real quick way to know. 1/2, the denominator says that I have 2 equal parts. So how can you put 12 in 2 equal parts? You guys knew that in first grade. What's the double for 12? It's 6 plus 6. So I know that 6 is half of 12, because 2 equal parts of 12 would be 6 in each part. So if she puts half on one page, 1, 2, 3, 4, 5, 6, and half on the other page, 1, 2, 3, 4, 5, 6, she uses up her 12 stamps. 1/2 of 12 is 6. See? You can do this. That's why we know our facts from before, and that's why we've practiced all the fractions we've practiced so far. Okay, another problem with the collection. I'm going to make a pile of 4 counters, just circles, pretend. If we were in class, I probably would have you have objects right now. So if you want to do fractions with some objects, you sure can. It's just hard to show you. I could do more Lego figures, but it gets a little tricky. So my pile of counters is 4. What is the whole of my collection? My whole collection is 4. All of these is my whole, okay? That's all my whole. What fraction of this collection is just one of these? Well, my whole is 4, and it's in 4 equal parts, so I'm guessing that my denominator is going to be 4. And if I'm only talking about, what are you talking about? Remember when we did that in class? What part are you talking about? I'm talking about that counter right there. And how many is that? 1. So one counter would be 1/4. How much of this collection would be two counters? Again, the same thing. I've got 4 equal parts, but what part am I talking about? That goes in the numerator. 2. 2/4 is 2 counters. I bet you're ahead of me now. Yep, you're ahead of me now. 3 counters would be 3/4. You got it. And 4 counters would be 4/4, which is equal to 1 whole. Okay? So that's what that set is. Okay, you can do that with any number of counters. We could have 8 counters. 1, 2, 3, 4, 5, 6, 7, 8. See them? Okay. What is the whole? Well, the whole is all 8 of these counters. It's in 8 equal parts. So 0/8 of this, 0/8 would be nothing. Because I'm not talking about anything. I'm not talking about 0. I'm talking about not whatever, you know what I mean. All right. So 1/8, you know it, would be 1 counter. 2/8, 2 counters. 3/8, 3 counters, and so on and so on and so on. I could have you sit and watch me forever. Okay, now I have another problem for you. This one's a little different. There are 8 crayons in a box. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's my box of crayons. Got 8 of them in there. How many crayons are in 2 boxes? Well, if I have to have another box, then it's got to be the same. 1, 2, 3, 4, 5, 6, 7, 8. So then I have 16 crayons, because I know 8 and 8 is 16. But what about 1 box and a half of a box more? It looks like this. 1 1/2. Well, 1 box is 8. And what's half of a box? 4. So 1 1/2 would have 12 crayons. So drawing pictures is really important when you're working with this kind of thing. Collections. Pictures will help you a lot. So don't be thinking that, oh, I drew it out, now I'm not that smart. That's not the way math works. Most people do draw it out in order to understand it, and then after they've done it for years and years, then they can keep it all in their head. All right, there's a couple more I want to show you. I've got 6 birds in a tree. There are my birds. Mine are flying away, though. Okay. 6 birds in a tree. 1 flew away. This one did. Okay. What fraction flew away? Think about the whole. The whole has 6 parts. What part are we talking about that flew away? That's how many flew away. Then the other question that would go with this would be, how many did not fly away? How many of them stayed? Well, again, your denominator, there's still 6 parts of this collection. 6 parts of the whole. And 1, 2, 3, 4, 5 stayed. Okay? All right. I think you're getting this. I think you're liking it. And if you're not liking it, too bad. Because we got to do it. All right. Susan shared 16 stickers equally with her friends. So she's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. She's got stickers to share. And it's Susan and her friend. Okay? Now the question is, what fraction did each person get if they shared them? Well, the question would be, how many equal parts do we need to put these stickers in? There are 8 stickers, but we want to put them in one part for Susan and 1 part for the friend. So we want them to be into 2 equal parts. So, how many did we say there were? 16. Do you guys know the double for 16? You sure do. So it would be 8 and 8. So 8 stickers would be 1/2. They each would get 1/2 of the stickers. Okay? All right, I think that's enough for today. I'm hoping you're understanding what we're talking about. And Hermione hopes so too, and so does the other Hermione, the Hermione twins. They must be from different movies though in this, because they're wearing different clothes. And the Harrys are different too. Here's casual Harry, and a little more preppy Harry, a little more dressed up, but they're both Harrys. And of course Ron is always around too. All right, your assignment today is to do Math Journal page 249. 249. And the box page is 250. And on your math boxes page on 250, let me grab it. There's a part that you're going to be confused with. I just know it. It says, complete the fraction number story. It's number 4. And they're talking about people eating pizza. Margaret is eating some. Justin is eating some. Connor is eating some. And then you need to know how much is left over. They give you the denominator of 8. That means that pizza was cut into 8 pieces. There's only one pizza. So you write the parts so that Margaret's portion and Justin's and Connor's and the leftovers should all equal 8 in the numerator. So you might do Margaret ate 1/8, Justin ate 1/8, Connor ate 1/8. That makes 3/8. So there'd be 5/8 left over for the pizza. So when you add all your boxes together, it should make 8/8. You can't just write any number you want to there. All right, if you have any more questions about that, please let me know. Math Journal, page 249 and 250. See you later.